Hello everyone. This video I'll be going over practice test 3 for MAT1033, and I'll start by just reminding everyone how to get to it. One of the ways to get to it, if you're just on the home page, when you open up Canvas, just scroll down, you'll find the practice tests, and I'm just going to go through practice test 3 like I mentioned. And I do want to remind you all, last time I wasn't here. If you're watching this, then you already know this, but there's the practice test videos now where I'll be putting this video along with being in the announcement. But also I'll remind you that if you're ever unsure about how the practice tests work, you can click on the practice test bonuses. And basically what it says as a reminder is if you get an A on this practice test, so at least a 90%, you will get a 3% boost on that test grade. So test 3 for this one. It is strict, meaning that if you get 89.9, you will not get that bonus. It's also not for a grade itself, so there's no real harm in trying to do the practice test. Maybe you just don't have time to do it all. The main benefit of the practice test is just like the other tests, it's very, very similar and should help you prepare for the real test. Right, so without further ado, I already have opened the practice test. I've opened it the way I can see it more easily to work it out for you. So you won't really see all the questions in here like this, but I'll do exactly what I did last time and just go through them one by one. What I'm going to do here is I'm just going to show you the problem. I'm going to write it down on my other screen, and then I'll move, once I have it written down, I'll move the screen that I'm going to do the work over so you can see it. Right. So number one, should have had better prepared to write down. Here we go. Number one, we want to evaluate p of negative 5 for this polynomial. And it is p of x equals x cubed minus 4x squared plus 3x plus 6. Right? And just like the last practice tests, in all the practice tests, there's pretty much no multiple choice. But on the real test, there will be that multiple choice like there has been for all of them. All right, so let's go ahead and work this out. What does p of negative 5 mean to do? All it means here is plug in negative 5 for x. So we got p of negative 5. Everywhere we see x in our formula, we replace with negative 5. So we got negative 5 cubed. Remember to always use parentheses when you're plugging in a number for x. It will ensure that you do not accidentally miss something. If you don't use parentheses, then there's a good chance you'll miss something. Minus 4, then negative 5 squared, plus 3x, which is negative 5, plus 6. And if you've got a calculator, you could probably do this all at once. I'm just going to do it step by step, not to skip too much. Negative 5 cubed is negative 125, minus 4. Negative 5 squared is positive 25, plus 3 times negative 5, there's no exponent, so we can just do that. Negative 15 plus 6. And maybe you're still not comfortable doing it all in the calculator at this point. You can sort of start to combine your like terms, and also 4 times 25 is 100. All I'm going to do is take care of that, and then I'll type in my calculator. So I got negative 125 minus 100, then plus the negative is just minus 15 plus 6. And then what does that equal? Just bust out your calculator, and we get, let's see what we got here. Get negative 234. And we know when we evaluate functions, plug in numbers, we get out numbers. Our answer happens to be negative 234. go ahead and make sure that is correct. And we're good to go. All right, number two, we want to factor the following expression completely. And we've got y cubed plus 6y squared minus 3y minus 18. All right, and when we want to factor it completely. All right, the one thing you want to remember about factoring like this, we have 4 terms, which means it's automatically going to be factoring by grouping. Right, and when we factor by grouping, the idea is to group the first pair of terms together and the second pair of terms together. So the first pair, we've got y cubed plus 6y squared. And what we want to do is, what is the greatest common factor out of that? Well, we have a y squared in each one. We can take that out. We don't have any numbers in common because y cubed just has a 1 on it. We're going to leave that alone, and we just get y plus 6 is what we're left with. And now similarly, we want to look at the second pair, which is negative 3y minus 18. Do we have anything in common there? There's no y's in common because 18 doesn't have a y on it. However, there is a 3 in common and also a negative. We can take out the negative 3. When we take that out of the negative 3y, we're left with just the y. And when we take that out of the negative 18, then minus becomes a plus, and 18 divided by 3 is 6. We get y plus 6. Now, once you're here, the main thing you can kind of check yourself with, did you factor correctly? Well, if these two insides are the same, which they are, that means you did it correctly. And what you do to finish factoring is you can take out the common thing, that's the inside, so y plus 6, and what your other factor is the stuff that's out front. So on the first part, we got a y squared out front, and the second part, we got a minus 3 out front. So our factoring is y plus 6 times y squared minus 3. Now, technically, you can factor this, but because it's not a difference of squares, y squared minus 4 would work. Y squared minus 3, not quite a difference of squares. This should be fine to use as our answer, but I'll check and make sure. And when we click on there, I'm just going to click on this to display the answer. We can see that it matches exactly what we got here. Y plus 6 times y squared minus 3. Number 3 now. Number 3, don't worry about that little warning. That's probably just a problem in the code the way it's written, but the answer and everything is fine. You will notice that for some reason this one doesn't have the answer button, so I'm just going to have to work that out, but that's okay. All right, so word problems usually pretty scary, but as long as you read them, they're often easier than problems like this above. You just have to read it carefully. It says a large explosion caused by metal debris causes metal debris to fly in the air with an initial velocity of 80 feet per second. The polynomial 80t minus 16t squared gives the height of the debris in feet t seconds after the explosion. Okay, so that's a lot of words, but really all we care about is that equation right now. There was some math that figured out that equation, but we don't really need to know how to do that. We just need the equation. And it asks, how long after the explosion does the debris hit the ground? Right. So really you just have to put a couple things together here, and it's not a bad problem at all. The equation we were given, the 80t minus 16t squared, that was the height. Go ahead and highlight that real quickly. All right, maybe that doesn't work as well as I was hoping. Never mind about that. Right. But we want to know where it hits the ground. Well, what does hitting the ground mean? That means the height is 0. So really all we've got to do is set our equation equal to 0 and solve it, since that's what it represents. So we got 80t minus 16t squared equals 0. Now what you've learned in this past section is that when you have something like this, you need to factor it because there's different powers of t. And when you factor it, it's always got to be set equal to 0, but it's already done for us this time. So we can just go ahead and factor it. And for factoring like this, you'll notice that we don't have 3 things, we only have 2 terms. So we take out the common factors. 80 and 16 have a 16 in common. T and t squared also have a t in common. We can factor out a 16t. When we do that, we've got 80 divided by 16 is 5, and the t is gone. The first term is just 5, minus 16 divided by 16 removes that entire thing. And when we take a t out of t squared, we're just left with a single t. And now that it's factored, we set each factor equal to 0, and we solve each one. All right, so don't forget, that's the easiest thing when you're learning this is to forget the thing in front because you don't really write it in parentheses. But we do have a t there, so we've got to set it equal to 0. And then the thing inside the parentheses, 5 minus t, also set that equal to 0. Solve each one of these. The one on the left, it's just 16 times t equals 0. You can divide by 16. 0 divided by anything is 0, and we get t equals 0. The one on the right, if you add t to each side, then you'll have t by itself, and it'll be positive. So that's the easier thing to do, and we get 5 equals t. Now this is a problem where there should only be one answer, because the question was how long until the debris hits the ground. Now since t represents time, t can't be 0, so it has to be the 5. On this one, it would be really, really easy to write the 2 answers because we're so used to working these problems where we have more than one answer and we just write them both in. Because it's a word problem, there's usually one answer for those, and our answer was 5. And so how long after does the debris hit the ground? It's 5 seconds. We just type in 5, and there we go. Number 4, another factoring one. We got 5y squared plus 17y minus 12, and we want to factor it completely. Bring it back over. The question is, how do we do this one? Factoring is a lot more straightforward if the thing in front, so in this case we have y, so it's y squared, is just 1y squared. But this is 5y squared. There's a lot of ways to do this. You can use guess and check. I'm not here in this video trying to change the way you do things. I'm just going to do it the way I like to do it, but I'm going to remind you there's guess and check. Most people like this. I'm not a big fan of it because I don't like guessing and checking because you might be guessing for a long time. You might just not see a combination and then think there's not an answer. There's the box method. And there's the AC method, which is kind of like the box method, but written differently. Right, so most people hate doing the AC method the way I do it because it seems like it makes the problem longer. But if you know how to factor by grouping, it's a way that always works and it's always going to work pretty quickly. Right, so the idea behind the AC method is you have your A, B, and C here. A is 5, B is 17, and C is negative 12. And we multiply A times C. That's why it's called the AC method. 5 times negative 12 equals negative 60. Now we just have to do that when A is not 1. When A is 1, you can just do the normal two numbers that multiply to this and add to that, so on. But here we've got negative 60, and what we want is we want the two numbers to multiply to negative 60. And add to positive 17, the B. Now don't get confused here because we have 5 and 12. Those don't work because we're going to need two numbers that multiply negative 60. That means one will have to be negative and one will have to be positive. Negative 12 and 5 make negative 7. Negative 5 and 12, the opposite would make positive 7. So those don't work. What other combinations are there? Well, the one that will work, 20 and 3 multiply to 60. If we make the 3 negative, then that will be the combination that makes them add to positive 17. So these are the two numbers we want to use. The question is, how do we use these two numbers? And once again, can be where at this point you do it the same way, and then from here you might do it differently than me. The way I use these, you write down your 5y squared that's in front, but you replace that 17y with 20y and negative 3y. So we're basically taking the 17 and we're changing it to 20 and minus 3. Because the 17 has a y on it, they each get a y. And then we just rewrite the minus 12. So all I've done here is, it looks like I made the problem longer, but the reason this is going to help us is now you can factor this by grouping. And I guess one thing that can be a cause for concern is, what if you did negative 3y first and 20y second? You'd still factor it by grouping and get the same answers. So it's all right. I just did 20y because I wrote 20 first, but I could do minus 3y. Right, I'm going to do factor by grouping. Luckily, in this video, we've already done one. We know we do the first two together. And then what's in common with the first two? Well, 5 and 20 have a 5 in common, so that's nice. And also, y squared and y have a y in common. We can take out a 5y, and then 5y out of 5y squared will leave us with just y. 5y out of 20y, the y will go away, and 20 divided by 5 is 4. Then check the second pair. Negative 3y minus 12. There's no y in common, but there is a negative 3 in common. And we take negative 3 out of the negative 3y, we just have positive y. Take negative 3 out of negative 12, that changes to a plus, and 12 divided by 3 is 4. And I shouldn't have written equals 0 because we're factoring that, so I apologize. We're not solving an equation. All right, but we're here, and just like last time when we factored by grouping, once you're here, as long as you have the same factor inside, which we do, y plus 4, we take that one out. And then the other factor is what's out front, 5y minus 3. And that would be our factoring. Now, if you're watching along and you prefer the guess and check and you were able to do it a lot faster, that is fine. You can do it whichever way you like. But this way, if there's a ton of combinations, this way will be quicker. If there's not that many combinations to guess and check, then guess and check will be quicker. So go ahead and make sure that's right. We have y plus 4 times 5y minus 3, and there we go. The order multiplication does not matter. Right, number 5 here. Number 5, we want to solve the equation that looks pretty nasty at the onset. We got 49x squared plus 84x plus 36 equals 0. Now, before I bring this over, I just want to go ahead and mention, because we have an x squared and an x, we have those many powers of x, we're going to have to factor this to solve it. Okay, so just keep that in mind. That was one of the big takeaways that you've learned throughout the new material, is that when you have different powers of x, to solve it, you need to factor. Right. Now, one thing is that you could look at this and think, oh, well, I have to do it like the last problem, because the number in front is not 1. We have 49 or 5 last time, 49 this time, and you can certainly do that. But there is sometimes special shortcuts, and this is one of them. 49 is a perfect square. Now, once again, if you don't like to memorize this shortcut and you think I'd rather just do it like the last one, then do that. But when you have perfect squares for A, which is 49, and C, which is 36, perfect square meaning it's a number squared. 36 is 6 squared, 49 is 7 squared. When these are both perfect squares, then the factoring is going to be set up for you to work like this. So we're going to have two factors. Since the perfect square on x squared is 7 squared, we're going to have 7x in front of both, coming from that 7. And then the 36, which is 6 squared, is just a number by itself, so it's just 6. And then the only other thing you have to do to finish up factoring is check this number here, or this sign here. If it's a positive, they're both pluses. Keep in mind this is positive 36, so they're going to have to be both pluses or both minuses. You just check the inside. Now, one thing I encourage you to do, especially if you want to try to use this shortcut, is just check and make sure this works. Meaning, if you FOIL it back out, do you get exactly this? So I'm just going to run through this really quickly because it's not part of the problem that we need to do, but 7 times 7 is 49x squared. Sorry, 7x times 7x. 7x times 6 is 42x. 6 times 7x is also 42x. And 6 times 6 is 36. Right, so you can kind of see the outside and the inside working, meaning 49 squared came from there, the 36 works perfectly. The middle number, 84, well, that 84 is 42 plus 42, which means that's good to go. Right, now the one thing is to remember, we are solving this, we are not just factoring it. Now what can we do now that it's set equal to 0 and factored? We set each part equal to 0. Because they're going to give us the same number, because it's the same factor, you only have to write it. You only have to write it once since it's the same factor. We don't need to write both since it's the same factor. All right, so we just have to solve 7x minus 6 equals 0, or plus 6 equals 0. To do that, we subtract 6 from each side, and we get 7x equals negative 6. And then we divide each side by 7, and we get x equals negative 6 over 7. Okay, we can go ahead and check that answer. Negative 6 over 7, perfect. Number 6 is another equation to solve. It's set up a little bit differently. We got to solve 7x squared equals negative 9x. Okay. But once again, even though it's written on each side, it's not written very pretty for us. The thing to notice here is that we have different powers of x, so we're going to need to factor again. And the reason I write the different powers of x, which means we need to factor, with the next thing that comes in line is we need 0 on one side. Right. So the easiest way to get 0 on one side, you can't just write 0, but we can add the 9x to each side, and that'll make the right side 0. So the 9x's go away, and we're left with 0 on the right side, and on the left side we got 7x squared plus 9x. These do not have the same power of x, which means it's already simplified. Right, and we're kind of working in reverse here. We know we need to factor from the beginning. We needed to get 0 on one side. Now that we've gotten 0 on one side, now we actually factor. And this is another one of those, like one of the previous ones, where we can just factor out the greatest common factor. And the reason we can do that is because there's no number here. We just have something with x squared and something with x. Right. And the greatest common factor here is just x, because 7 and 9 have nothing in common. But x squared and x have an x in common. When we take the x out, the first term becomes 7x, and the second term becomes 9. Now, once again, the easiest thing to forget here when you just do this factor out the greatest common factor is forget about the thing that's not in parentheses, but we cannot forget about this x. We got to set the x equal to 0, what's in front, and then the thing inside, 7x plus 9, equal to 0 as well. Luckily for us, this one's already factored because x equals 0. Now 7x plus 9 equals 0. We subtract the 9 from each side. We get 7x equals negative 9. And then we divide by 7, and we get x equals negative 9 over 7. Well, we've got two answers here. We got 0 and negative 9 over 7. Again, just show the answers to make sure everything works here. And there we go, 0 and negative 9 over 7. One thing I like to mention, especially about this problem, is it's really easy to want to divide x on each side at the beginning. You are never allowed to divide by a variable. And what will happen if you divide by that variable, I'm not going to work it out, but you'll actually only get one answer of the negative 9 over 7. You won't actually get the 0. So that's something to beware of. Never divide by x. Number 7. Number 7. We want to solve the equation p squared equals negative 2p plus 48. Very similar to the previous two. We're solving an equation, and we have different powers of p. But what we're going to have to do is we're going to have to factor. Just like before. So we got p squared, writing it down, equals negative 2p plus 48. And just going to point out the same thing as last time. We have different powers of p, so we need to factor. And because we need to factor, we need 0 on one side. All right, so the rest down here is just telling you to separate your answers by a comma, but we've already done that in the previous problem. All right, so how do we want to get 0 on one side? Excuse me. All right, so the easiest thing would be to subtract p squared because that would be only one thing. However, I like the p squared to be positive. If I subtract it, it'll become negative. For that reason, I'm going to add the 2p and subtract the 48 to the left. The right side will become 0. The 2p's go away, the 48's go away, and we got p squared. Actually, that might be a little too bright. Let me use a different color. P squared plus 2p minus 48 equals 0. Now, luckily for us, this one is one of the quote-unquote easier ones to factor because it's just p squared. But we need two numbers that multiply to negative 48 and add, see if I can learn how to spell and, excuse me, add to positive 2 on the 2p. We know the front's going to be a p on each. We also know that one's going to be a plus and one's going to be a minus because we have a negative 48. And 48 can be gotten from 6 times 8. Because we want positive 2, we would use 8, and negative 6 would be those two numbers. But we've already got it factored here. Now we can set each factor equal to 0. P plus 8 equals 0, and p minus 6 equals 0. And when we solve the one on the left, we just have one step, subtract the 8, and we get p equals negative 8. And the one on the right, we add 6 to each side, and we get p equals 6. We've got two answers. We got negative 8, and we got 6. Go ahead and check and make sure that these are correct. Go back to the homework here, the practice test, and we see negative 8 and 6, exactly what we got. We're good to go. Right, number 8. Number 8 here, we're trying to figure out the domain of a rational function, meaning the domain of a function with a fraction. The only thing you have to remember, so it's asking what is the only value of x not in the domain. The thing you have to remember is the denominator cannot be 0. The question is, what is the only x value not in the domain? Well, like I just mentioned, the denominator cannot be 0. So the idea is you set the denominator equal to 0, you figure out what x values you get, and those are your answers. All right, so luckily for us, the denominator 5x plus 6, when we set that equal to 0, it's not too bad. Just a quick equation to solve here because we only have x. We subtract 6 from each side. We get 5x equals negative 6. And then we divide each side by 5. And we get x equals negative 6 over 5. Once again, go ahead and check that we got it right. Actually wrote it as a decimal. If you type in negative 6 over 5 into your calculator, you'll see it as negative 1.2. So that works. I'll just type in negative 6 over 5 to clarify. All right, number 9 here, we're back to solving an equation. And we want to solve equations with a fraction. We got 5 over x minus 1 equals negative 1 over x plus 5. All right, so the question is, how do we solve this? Well, whenever you're in a situation where you have, go ahead and erase that. Whenever you're in a situation where you have just a single fraction on each side like this, the easiest thing to do is cross multiply. That'll get rid of your denominators. It's kind of like multiplying by the least common denominator here, but you're taking a shortcut. So we got 5 times x plus 5 equals, when we multiply the x plus 5 over to the 5, and then on the right side we got the negative 1, that's multiplying the x minus 1. Okay, so now we want to solve this equation. Got to get rid of the parentheses, which means we'll just distribute on each side. You get 5x plus 5 times 5 is 25 equals negative 1 times x. And then negative 1 times negative 1 is positive 1. And now this is an equation that we've been solving for a long time in this class. Get the x's on one side and the numbers on the other. So I can move the negative 1x to the left by adding it. And if you want to write just x instead of 1x, that's fine. And I also want to get rid of the 25 to get it to the other side, so I'm going to subtract 25 on each side. And what do we have here? The 25's go away, the 1x's go away. 5x plus 1x is 6x equals, 25's are gone, 1 minus 25 is negative 24. And to finish up, to solve for x, we divide each side by 6. And we get x equals negative 24 over 6 is just negative 4. Now this is our answer, but we do have to make sure it works. Remember, when we have x's in denominators, there are numbers that we cannot use. We have to check that this doesn't make any denominator equal to 0. Now you can plug it into the original, you can plug it into just the denominators, it's fine. I'm just going to plug it into the original to avoid confusion. So we got 5 over negative 4 minus 1 equals negative 1 over negative 4 plus 5. Make sure this works here. On the left side here, we've got 5 over negative 4 minus 1 is negative 5. And negative 1 over negative 4 plus 5 is 1. Now, as soon as you see that the denominators do not equal 0, you're fine. You don't have to go any further. But if you want to just simplify and super make sure, you can. 5 over negative 5 is negative 1 equals negative 1 over 1 is also negative 1. But it does, in fact, work out. I can still check the answer here, so you can see that negative 4 is, in fact, our answer. All right, number 10 here says write the equation for the vertical asymptotes of the graph below. This one, there's not really much work to do. The main thing is to remember that the vertical asymptotes are these vertical red lines that are dashed, and you just have to make sure they are equations. So the one on the left asymptote is at negative 1, but it's got to be a vertical line. It's x equals negative 1. And then the one on the right is at 3. Because it's a vertical line, it's x equals, and then the number 3. And you submit, and you see it works. Now the thing you have to be careful on is you need these x equals. So I'm just going to do this for the purposes of explaining. If you don't write the x equals, it'll tell you you have an error. So it automatically won't work. If I get a similar problem, just to stress this, if I just type in negative 1 for the left, since this one's at negative 1, and the one on the right is 4, so I'm going to type in 4. You can see that it does not work. You have to type in the x equals. Number 11, simplify the following expression completely. And we've got a fraction here. We have 5x. Let me write down simplify. We've got 5x plus 35 over x squared plus, it says 1x. You can write 1x or just write x if you prefer, minus 42. Simplify completely means we're going to hopefully factor the top and bottom and cancel out any common factors. So I'm just writing that on this sheet before I move it over, but that's what simplify completely means. We're going to factor the top, we're going to factor the bottom, and if there's any common factors, we're going to cancel them. All right, so let's go ahead and do it. I'm going to rewrite the problem down here just so I can write it in line. 5x plus 35 over x squared plus x minus 42. Now the factor doesn't, the top doesn't factor in a normal way, but we do have something we can factor. 5 and 35 have a 5 in common. We can take a 5 out. And when we do that, we take a 5 out of 5x, we're left with x. When we take a 5 out of 35, we're left with 7. So the top does factor a little bit to this. And now the bottom factors as well. This is an x squared, which means we're going to have two factors with just an x. And we want two numbers. Because it is x squared, we can do the shorter one. Two numbers that multiply to negative 42 and add to 1. Because it's going to multiply to a negative, I'm going to do a minus and a plus. And the two numbers that work here, 7 and 6 multiply to 42. Which one's going to be positive? It's going to be the 7 because they have to add to positive 1. So 7 and negative 6 work. It means I'll have x minus 6 and x plus 7. Right, but you can see we do in fact have some canceling that's going to happen because we have an x plus 7 on top. Cancel that out. And once we cancel that out, what we're left with is our simplified answer, 5 over x minus 6. Right, so especially with problems like these where you're simplifying a fraction, when you factor, you're probably going to get a factor that's the same on the top and bottom. Just be on the lookout for that. If you don't get one, highly unlikely that you did it correctly. You may have made a little mistake on the way. Let's go ahead and make sure our 5 over x plus 6 works. X minus 6, and it does. Oh, I know I said x plus 6, but we had x minus 6 just to remind you. Right. Number 12, same directions, but because both parts are squared on the top and bottom, it'd probably be a little more work to do. But the idea is going to be the same. We got 3x squared plus 7x plus 2 over 3x squared plus 13x plus 4. And we want to factor the top and the bottom and cancel out anything that does cancel. Now normally, like I did the one before, if there's not a 1 in front here, then it can take a while. The other option is to use guess and check. And there's not going to be that many combinations here, so I'm going to use guess and check. The reason I know there's not many combinations is, for one, if we have 3x squared in front, one thing's got to be 3x and another one's got to be x. That's the only possible combination. And same thing for the bottom, because there's a 3x squared. It's got to be a 3x and an x. Another little handy shortcut you can use here is that because you have a plus 2 on the 2, so it's got to multiply to positive 2, and you have a plus here, both of these are going to be pluses. Same thing for the denominator, you have a plus on the 4 and a plus on the 13, so they're also both going to be pluses. Once again, I'm just doing this the way I see to do it. You've done a lot of these problems on your own by now. Do it the way you prefer, and maybe the way I'm doing it makes sense to you and you prefer to do it this way. Right? But for the top, we have some blanks here. This is where we implement the guess and check method. We need two numbers that multiply to positive 2 for the top, and for the bottom they have to multiply to positive 4. Right. So the reason why there's not many options here is for the top, there's only two possibilities. You have 2 and 1, or 1 and 2. Now the reason why the order matters here is if I put a 1 here, all right, let me go in order. So I wrote 2 and 1 first. If I use a 2 and a 1, then when I FOIL it out to check, it's going to be different because one of these has a 3 in it and one of them does not. All right, so will this one work? So I'm going to just check down here. Does 3x plus 2 times x plus 1 give us 3x squared plus 7x plus 2? So when we do the 3x and the x, we get the 3x squared. When we do the outside, 3x times 1 is 3x. The inside 2x, 2 times x is 2x. And then the 2 times 1 is 2. And the middle 3x plus 2x does not equal 7x. So that one won't work. Well, that means it's got to be the other combination because we only have one other combination. It's 1 and 2. Let's go ahead and check it down here. I'm going to go ahead and remove or switch out the 2 and the 1 as well. I know that checking can be a little annoying, but an important thing to remember is that when you only switch the order of the two numbers, the 3x times the x will remain 3x squared, and the 1 and the 2 will remain 2. So you really only have to change these numbers to what they're going to become. 3x times 2 is 6x, and 1 times x is just x. And this time, does 6x plus x equals 7x? Yes, so this is the combination. And then for the one on the bottom, what pair of numbers multiply to 4 if they're going to be all positive? Well, we have 1 and 4, and 4 and 1. And then we also have 2 and 2. So I'm just going to check here which one works. And I'm following this same format as before. So I have 3x plus the number I'm going to put in for the first one times x plus the number I'm going to put in for the second one. And I'll start with 1 and 4. 3x times x is 3x squared. 3x times 4 is 12x. 1 times x is x. And 1 times 4 is 4. And does this equal 3x squared plus 13x plus 4? And we actually got lucky in the first choice here because it does. The 12x and the x make the 13x. And that means a 1's going to go with the 3x, and a 4 is going to go with just the x. All right, so it takes a little bit of time. One thing to remember that I mentioned before is that very often on these, you'll have a factor on the top and bottom the same, and if you do, it means you probably did it correctly. We have the same factor, 3x plus 1, on the top and bottom here. What we can go ahead and do is just cancel them out. And we are left with just x plus 2 on the top and just x plus 4 on the bottom. So quite a bit more work for this one. We had to factor both the top and the bottom. Not both of them we had to use guess and check method. But do we get x plus 2 over x plus 4? We do indeed. Number 13. So a more recent homework topic, maybe, just from last week. We want to divide and simplify. And I've got x squared minus 7x minus 30 over x squared plus 10x plus 21 divided by x squared minus 100 over x squared minus 49. Well, the idea here is the same, it's just a more complicated version of the first one, or the previous two. We need to factor everything, cancel out. The issue is, for me, I'd never like to have division with fractions. So fraction divided by a fraction, I hate it. But we can change the division to multiplication if we flip the second fraction. Right. So what this is going to look like, I'm not going to do any factoring yet. I'm just going to rewrite it. We got x squared minus 7x minus 30 over x squared plus 10x plus 21. And then I'm going to change division to multiplication. And I'm going to flip this fraction. So I'm going to have the x squared minus 49 on the top and the x squared minus 100 on the bottom. Now at this point, factor everything. I'm going to factor the top on the first fraction, the bottom on the first fraction, the top and the bottom on the second fraction. Luckily, these are all just x squareds, which means we don't have to do guess and check. I'm going to write it directly underneath. I'm going to go ahead and just fill in all the parentheses first to make it a little easier to set up. And since they're all x squareds, we're going to have all x's. You don't have to do it like this. I just like to get it set up. We're going to be writing down a lot anyway. For the one on top here, just kind of read it as to what we're putting in. We want two numbers that multiply to negative 30. And then add to negative 7. 30 would be 10 times 3. Because it's negative, we're going to have one of them is going to be negative, and the 7 is negative. So it's going to be negative 10 and 3. Negative 10 and 3 work. We're going to have minus 10 and plus 3. And going from that one, and then this one here, the one on the bottom, same sort of idea. We want two numbers that multiply to positive 21 and add to positive 10. Because that's all positive, that's really a little bit easier to do usually. We've got 7 and 3 that work. They multiply to 21 and add to 10. Now for the second fraction here, what you have to remember, these are both difference of squares. And the difference of squares, what you do is you have an x in front of each, like we do here. And what is 49 the square of? That is the square of 7. So since 49 is 7 squared, that's going to be x plus 7 and x minus 7. Hopefully you remember that difference of squares. And then also for 100, that is 10 squared. That's going to be a plus 10 and a minus 10. I'll just remind you, x squared minus a squared equals x minus a times x plus a. What that's telling us is that you take the square root of that number here, and the numbers that go in your factor are plus and minus that number. Right, it looks incredibly messy, but now we want to cancel. Right, this first fraction here, we can see on the top we got an x plus 3. That cancels out with the x plus 3 on the bottom. Now, one thing is, since this is multiplication, don't forget that things on the top over here can cancel with things on the bottom anywhere. So x minus 10 cancels with the x minus 10 over here. And I just like to go across the numerators, see what cancels and what's left. X plus 7, do we have anything to cancel out with? We do. There's an x plus 7 down here. And then what's left? X minus 7, does that cancel with anything? No. No, in fact, it came all the way down. We only have one thing on the top left, which is x minus 7, and one thing on the bottom left, which is x plus 10. And go ahead and check that that works. There we go. X minus 7 over x plus 10. Right, number 14. Number 14, we want to add and simplify. We got 6x plus 3 over x minus 5 plus 10x over 5 minus x. Okay. It says enter the numerator and denominator separately, which means when we get our answer as a fraction, we're going to have to do the numerator on the top here, the denominator on the bottom here. And it does say make sure that the coefficient on x is positive. Okay. So just to talk about that very quickly, what it means is that one denominator is x minus 5. The number on the x is positive. There's an invisible 1 here. The 5 minus x, the number on the x is a negative 1, which is negative. We're going to have to get rid of the negative on here. So keep that in mind. We want to change this denominator into this denominator. Right, the question is, how do we change 5 minus x into x minus 5? Because if we do that, then we'll have the same denominator, which means we can add them together. Well, anytime you have the order backwards here, so x minus 5 is flipped of 5 minus x, all you have to do is multiply by negative 1. The one thing you got to be careful on is you have a fraction here, which means if you multiply by negative 1 on the bottom, which is what we're going to do, you also have to multiply by negative 1 on the top. Keep the equation balanced. What you do to the bottom, you must do to the top. Okay. So when we do that, we got 6x plus 3 over x minus 5 plus 10x times negative 1 would be negative 10x. Now, 5x times negative 1, I just want to write it what it looks like on the side. 5 minus x times negative 1. Because this has a plus or a minus, you actually have to write a parentheses and distribute, just so you can see that it does work. And when we do that, we got a negative 5 times negative x, or plus negative x times negative 1 would be double minus, gives us a plus x. And because it's addition here, we can switch the order. We got the same thing as x minus 5. So we can see that it does in fact become the same denominator. Now we can add the numerators together because the denominator is the same. We got 6x plus 3 minus 10x over the common denominator of x minus 5. Remember, once you have a common denominator, you just leave it. And then you simplify the top. 6x minus 10 is negative 4x. And then we've got our plus 3 over x minus 5. Okay. Our final answer here is negative 4x plus 3 over x minus 5. We kept the coefficient on x positive, like it wanted us to. And just so you can see the answer again, do we use the top negative 4x plus 3? Yes. Is the bottom x minus 5? Yes. And so we're good to go on that. Number 15. Number 15, we have similar, since this one's kind of straightforward in the same directions, I'm just going to write it on the screen with you. We've got 6 over x minus 4 plus x minus 52 over x squared minus 16. We want to add and simplify. All right. So what did we do last time to be able to add and simplify? We figured out what we had to multiply the denominator by to make it the same. Well, we have to do the same thing here. We want the denominators to be the same. One thing that's very helpful is to factor this denominator. Since we have an x squared, we can factor it, and it'll tell you what you need to do. So I'm going to rewrite everything else in the problem. I've got 6 over x minus 4 plus x minus 52 over, and this is another of those difference of squares where 16 is 4 squared. It means it's going to be x minus 4 times x plus 4. So what you can see here is that this denominator has an x minus 4 in it, which is over here, but it also has an x plus 4. To make them the same, we have to multiply by the x plus 4. Oh, whoops. That was going to be an undo button. My apologies. Then we want to go ahead and multiply by x plus 4, this fraction. Like before, what we do to the top, we must do to the bottom. I like to just write it in parentheses, just to be safe. I don't want to forget. But once we have that written out, you can see it's going to simplify. What I would recommend doing first before combining the fractions is to multiply this out. Okay, so I'm going to rewrite everything else that we have so far. We haven't done anything to the x plus 52 at all. I'm not changing the x plus 4 times x minus 4. Probably not change the order. So x minus 4 and x plus 4 are the denominators for each as we want. And then when we distribute 6 to the x plus 4, we get 6x plus 24. Oops, let me not use that same color again. And now we can combine x minus 4. I keep wanting to write the plus first. I don't want to change the order. Keep it the same. Our common denominator of x minus 4 times x plus 4 is there. And now we can combine the numerators. 6x plus 24 plus, now we don't really have to do it here because it's a plus, but in general, when you have to add something that has a plus or a minus with it, you like to put in parentheses x plus 52 to make sure you distribute whatever's there. Luckily for us, it's just a plus sign, which won't change anything this time, but we don't want to forget that. And we got 6x plus x is 7x. 24 plus 52 is 76. Now at this step we might think, okay, we need to factor the top and see if it cancels. Luckily for us, 7x plus 76 does not factor, which means this will be our final answer. It might want us to multiply the x plus 4 times x minus 4 back. Actually, I must have missed a number because their equation is way different. Let me see what I missed. Oh, I didn't even realize it as I was going, but it's x minus 52 in the problem, and then I changed it to x plus 52. So if you're following along, you probably thought, why did I change that? I did not mean to change that. It should be x minus 52. And then that's going to be a minus down here. 24 minus 52 is negative 28. I get rid of this, and let me also get rid of that box. And that plus needs to be a minus. Okay. 24 minus 52 is negative 28. And this time we can factor because there's a 7 in common with 7 and 28. When we take the 7 out, we get x minus 4 over x minus 4 times x plus 4. And when we look at this, it's factored and we have an x minus 4 in common. We cancel that out and we get 7 over x plus 4. And that's what it was showing us. So minor mistake, but happens to the best of us. All right, so I'm going to end this first video here because it's 30 problems and done with 15, so we're halfway done. I plan to have the second video up at the same time the first video comes up, but just in case it's not up at the same time, it will be up shortly.